Hi everyone, here we will discuss about maximum matching using the bipartite graph. First we know what is the graph. Graph is having set of vertices and edges. Then this set of vertices can be divided into two disjoint subsets. So here, for example, V is having six vertices 1, 2, 3, A, B, C. Then these are going to be divided into two subset, distinct subset. That means any vertex which is available in the subset 1 should not be available in the subset 2. So the given vertices should be divided into two disjoint subsets. Then we can say in bipartite graph the set of vertices can be said v1 union of v2. You look at that, v1 is having 1 comma 2 comma 3, then union of v2 will give you the set of vertices. Like that, when you are applying the intersection operation, v1 and v2 are not having the sharing vertices, so we can say that is empty set. So here there is no common vertex from both subsets. These disjoints v1 and v2 need not to be the same size. For example, you see this is v1, this one is v2. So the v1 is having 3 number of vertices, but v2 is having 5 number of vertices. So this is also bipartite graph. So bipartite graph need not to have the same number of count vertices in both subsets. Here each edge is connecting one vertex from the subset v1 and one vertex from the subset v2. That means here you see the subset v1 is having 3 vertices. This vertex should connect with any one of the vertex from the subset v2, right? Like that, here another vertex also should connect with any other vertex from the v2. So that is called bipartite graph. Then we can say every vertex of subset v1 is connecting with every vertex of another subset v2 is full bipartite graph or complete bipartite graph, or another name is biclic. Okay, you see here the vertex available from the v1. So here you say this is a, this one is here 1. The a is connecting with all the vertices in the subset v2. Like that, b is also connecting with all the vertices in the v2. c also connecting with all the vertices of v2. That means if every vertex of subset v1 is connecting with all the vertices of v2, then we can say that graph is called complete bipartite graph or biclic. Then we can identify the matching by using the bipartite graph. Here the matching is defining as connecting the pair of vertices from two distinct set of vertices. That means here we will have you see the subset v1 is having 3 vertices, subset v2 is having 3 vertices. So here we are connecting the vertex from v1 with the vertex from another subset v2. So that is called matching. When we are doing that matching, we should satisfy this property. That property is here, each edge should have only unique endpoints. That means no two edges can share the same vertex. You see here, this is bipartite graph by establishing the connection between two subset of vertices. Then we have to check, is it bipartite matching or not. So when you are checking that, the property no two edges sharing the same vertex, but here you see edge number 1, 2, 3, 4. So from this, 1 and 2 are sharing the vertex 1, then it is not the bipartite matching. Okay, so it is not bipartite matching. Like that, the vertex of the v2 is having two edges. That means b is sharing by the edges 2 and 3. So this is also another possibility to say this is not bipartite matching, right? The graph is bipartite graph, but that is not bipartite matching. Okay, and here how can we update this as a bipartite matching? Here you see I am updating that one is matching with B and 2 is matching with A in the V2, right? Then 3 from the V1 is matching with the C in V2. So here I am making that this property is satisfied, right? So no two, I mean, there is no vertex is sharing by two edges. So each vertex is having only one connection, right? Then we can say this is called bipartite matching. Now we will use the example to explain about a bipartite matching by using the property two edges should not share the same vertex. So here we have to identify maximum number of matching. Previously we have seen matching, right? Now we have to check what is the possibility of maximum number of matching by using the bipartite matching concept. So for identifying the maximum number of matching, we can calculate the maximum number of edges which are connecting in this problem. So here you see one is connected with another vertex from the V2. Then we have to calculate 1 2 3. So we have to identify the sum of the edges which are connecting the vertices from subset V1 and subset V2. So now we found the maximum matching of this bipartite problem is 3, right? So here maximum matching is 3. Once we found the maximum matching, we should not add any more edges. Okay, so if you add any more edges, then it is not contributing to maximum bipartite matching. You see, when I am adding new edge to vertex number 2 from the V1 to vertex A in the V2. So when we are adding like this, then what is happening? This A is sharing by edge number 1 and new edge 4. So the property is not satisfied here. So what we are saying here, if you add any more edge, then that solution is not contributing towards the matching. So that's what we are saying here. We should not add any more edges after finding the maximum matching, but there is the possibility of more than one maximum matchings for a given bipartite graph. You see, so this is one maximum matching. We found 3 as the maximum matching. Then you see here 1 is assigned to B, 2 is assigned to A. The jobs are changed now. Okay, jobs are changed to employees, but even though here no two edges are sharing same vertex, so this is also another kind of bipartite maximum matching. Then we can identify so many number of maximum matching. So here another one maximum matching. Here you see one is sharing with C, 2 is connecting with A, and 3 is connecting with B, right? So 1 is connecting with C, right? So not sharing, connecting with the C, right? So here you see in the first maximum bipartite matching, one is connected with A. In another bipartite matching, one is connected with B. In another bipartite matching, one is connected with C. So like this, there is the possibility of more than one maximum matching for any problem statement. Okay, so based upon that, we can say the maximum bipartite matching by using different example. Here M is having 5 number of employees, N is the another subset which is having 5 number of tasks. Then we have to identify the maximum matching here by using the bipartite graph. So based upon that, here I am giving the problem statement. So here 5 number of employees and 5 number of jobs or tasks. So here these are all jobs or tasks, so these are all employees. Okay, so then from this we have to identify the matching. You see, I am matching 1 to 7, then 2 to second employee is doing the job 6, and job 8 is assigned to employee number 3, job 9 is assigned to employee number 4, job 10 is assigned to employee number 5. We can give another kind of matching also. You see, 1 can be assigned to 6, okay, then 2 can be assigned to 7, then 3 can be assigned to 8, and 4 can be assigned to 9, and 5 can be assigned to 10. You see, this is another kind of maximum matching. Here also we got 5 is the maximum matching. Here also number of edges 1, 2, 3, 4, 5. So here also maximum matching is 5. So what kind of whatever kind of maximum matching you are applying, we have to get maximum matching value here from the given problem. After identifying the maximum matching, if you add any more edge here, you see, this is not contributing towards the maximum matching because the 7 is sharing by the two edges. So we should not add any more edges after finding the maximum matching. So this is one of the example. Then the same maximum matching can be solved by using the graph colors method. Previous one is we identified using the edges, okay, that now we are able to identify the maximum matching to by applying the graph coloring. In the graph coloring approach, no adjacent states will be applied with the same color. That means here you see, the vertex A is having adjacent vertices. Here the adjacent vertices should not have the same color. So A is connected with these three, so all three are having here you see A to B green. So here this is red, so different color should be given green. Here again A to C, A is red, so we can give the green. Why we are giving the green to these two nodes? Because we have to minimize the number of colors. We have to minimize the number of colors when you are applying the color to the vertices. But here we have to identify maximum number of matching, right? And here D is having but D is connected with B and C, both are having green color. That's why we are not giving again a green color. Red color also we cannot give because A is having the red color, so then we are going for another color D. So using the graph coloring method also we can identify the maximum matching with the bipartite graph. You see, vertices can be colored using two colors. The subset 1 employees, subset 2 tasks. Then we can identify the matching by connecting the vertices from the two disjoint subsets with the property here two edges should not connect, I mean share the two edges should not share the vertices. That is called maximum matching, right? So now here when you are applying this, vertex 1 should have single color, I mean subset 1 should have simple, I mean single color, and subset 2 should have another color, different color, because here in the bipartite matching we are going to match with the any vertex from subset 1 with any vertex from subset 2. So two colors are sufficient here. That's why it is called two colorable graphs. So the given problem statement is this one. This is the bipartite graph. From the bipartite graph we have to identify the maximum matching. What is the bipartite graph? Bipartite graph in the sense vertex from subset V1 should connect with another subset vertices, okay, any vertex from another subset V2, right? So you look at that, it is satisfying. So vertex A is connected with another subset vertex 1, right? And vertex B is connected with two vertices, right? 1 and 2 from the subset V2. C is connecting with two vertices from the subset V2, right? 2 and 3. So here we have to identify the maximum matching. What is the property here, right? So two edges should not share the same vertex. So but here sharing is available, so we have to modify that, update the problem, right? So now the A is assigned with the third job, and B is assigned with the first job, then C is assigned with the second job. So now you see there is no vertex is sharing by two edges. So this is the maximum matching of this given problem statement. Count the number of edges now. 1, 2, 3. So maximum matching of this given problem statement is now 3 is the maximum matching. Thanks for watching.